Welcome to the Rabbit Hole, episode 110.
Oh,
Different. Oh, well, I guess everything is always different, but an interesting topic regarding transients.
yeah.
So I think first we have to talk about what are transients and based on what are we doing the show today.
Yeah.
But we're basically doing it based on the work by Dr. Beatriz Villarreal, which is a researcher in the astronomy at the Nordic Institute of Theoretical Physics, Nordita in Stockholm. And she's actually the lead of a project called VASCO, which means vanishing and appearing sources during a century of observations.
Yeah.
And she's also in another project called ExoProbe. And among other things, she's also in the Sol Foundation, which is a foundation where also Gary Nolan, I think, helped to found in general. So this is what we're talking about. This is our topic of today. And I guess the first thing we need to talk about is what actually are transients, right?
I think that would be a good place to start.
So you want me to mention also this part?
Yeah.
So basically, transients are like points or star flashes or, points that appear in photographic plates, exposures,
Temporary.
that are taken in a certain moment and afterwards they're not there anymore.
Yeah.
This can be, I don't know, a month after, a day after, now 20 years after, you cannot find it anymore in the same
Right.
positions, right?
But I think
So-
the key thing about the work that she did was that she took plates, photographic plates,
Mm-hmm.
from the mid 50s. So obviously proper photographic plates of like sky surveys.
Mm-hmm.
And I think it was from an optical telescope, earth-bound optical telescope, because that's all there were at the time. And crucially, is the pre-satellite era.
Yeah, I think that's the one most important part, I think,
That is crucial.
or one of them, because there's actually another one. But yes, the fact that it was made on plates taken before all the space era,
Yeah, so it's
before Sputnik.
pre-Sputnik. Right? Yeah.
Yeah.
And the other thing, maybe just to point out, is that these kind of sky surveys, the way they do them, it's not like you can imagine the telescope is just a huge camera that you just point at the sky and take a picture, because obviously the light sources can be very dim.
Mm-hmm.
They actually expose the plates for periods of time.
Yes.
So basically, what she was looking for, or what she looked for, were these transient events, which she characterized as potentially being light reflecting off a metallic surface of an object that was potentially turning, or
Mm-hmm.
and that because the plates were exposed for a period of time, these transients form into a line, because it's the same object, but as it's turning, it is reflecting the light, to later period.
Yeah. And all started because of one question that she had, or she put herself while making the research, which was if an object could just vanish.
Right.
Now, modern day presents a big challenge because we are full of garbage in space. We have lots of satellites and things that sometimes we don't even know what's really up there.
Bits of rockets.
Yes, and that's why she chose all plagues from surveys pre space era,
Yeah, exactly.
and from the Palomar Observatory was the main source for all these plagues.
Right.
And there's another interesting part. While starting the study, actually, she realized that there could be other things that could reflect the light. So to make it even, how can we say it, better,
more rigorous,
rigorous,
yeah.
she took the surveys and plates that were taken during the umbra phase of Earth, which means there's no light that can interfere directly from the sun over the exposure of the plates.
Yeah.
So I think that was another important step to make, like you said, more rigorous and more strict analysis of her investigation.
And also, she had to acknowledge, take into account the fact that these plates, because they're photographic plates, so they're coated with a very fine photographic emulsion.
Yeah.
The plates themselves, the emulsion can have faults in it that produce false points, shall we say, artifacts. But she had a method for identifying, characterizing them, and then eliminating them from the analysis, right?
Yeah, exactly. And yeah, go ahead.
So one of the shall we say criticisms that were initially raised was, these could be just damaged emulsion, and it had to be addressed, or else it would obviously, shall we say, undermine what she was trying to explore. It turned out that plate damage could be characterized in that the damage tended to be towards the edges of the plates, and also the apparent light source that the damage was mimicking was not, had a particular characteristic about it, it being not in any way symmetrical or something. It had a particular kind of form. So they were able to eliminate, hopefully, the vast majority.
Yeah.
And then what they were looking for in the end was kind of point events. I think we can see there on the trace. There are some images where the at the end of the paper there are actually some events where the lines are to show the tracking
The tracking,
line.
exactly.
So if you can imagine these things on these images, they can actually draw a line through the images. So here's the thing. So what could those objects be that are in these sky survey images, and they appear to be um, following a linear orbit or track, when it was a period prior to there being any satellites?
Exactly.
So,
Yeah.
so what are they? In the paper, she did raise the, shall we just say, coincidence that two of the events were actually coincident with a UFO activity, or alleged UFO activity. The main one being that DC
Yeah.
scare that there was, and it was, the plate that showed a clear one of these events where there appears to be an object moving across the plate was, I think, the same day as the
Yeah.
DC
Oh,
event.
yeah, exactly. And but there's also one more thing that she managed during the investigation to realize, which was it was not only coincidence that appeared these transient objects during that moment of UAPs appearing around, but also nuclear testing sites. So there was an interview with Gary Nolan also talking about, well, to probably try to prove if there would appear some kind of transients nowadays. It's a bit hard because it's not like you can just detonate a nuclear bomb, right? Just to test, make a test and give me a nuclear bomb and I will test it somewhere and see if something appears in the sky.
See what happens. Yeah. And of course, with all the clutter anyway, and blah blah blah.
Yeah.
I think it's worth pointing out though that she doesn't draw firm conclusions.
Yeah.
She is just pointing out that there were these, shall we say, coincidences of these identifiable events in the sky surveys and things that were going on, shall we say, on the ground. So she is not. She is basically leaving it because it's speculation, isn't it? And
yeah, she based a lot in just in proof and in testing and
exactly, and
methodology. Yeah,
she applies a very rigorous, a scientifically rigorous approach, and uses these certainty factors that they use in, like with the Large Hadron Collider when they're looking for new particles or new fundamental particles. They have to reach what's called a significant sigma value, which is the probability that what is being observed is certain enough to be classed as an actual discovery. And I think it goes up to 5, I think, the sigma rating, I think. And and you have to be up at, kind of
above 3 or something like that.
I think it's 3.5 or something. And she, in her work, calculated sigma numbers for these things, and she got up into the low 3s, I think. So, I mean, obviously, the thing is, these plates are like 70 years old, right? 75 years old.
In fact, yeah. I mean, they're super old. I mean, imagine they're from like 1952.
Yeah, perfectly usable, but...
Yeah. In fact, this part, I think, is one of the top points. Let's say if we can mention some points that are against her study or trying to debunk the study or try to prove it wrong, is exactly this thing of the photographic emulsion or artifacts that are being copied. And they are saying that this could be introduced while creating copies of the plates, basically. Another argument is the digitization or scanning of those plates to convert to digital. Could be dust, scratches, anything that could be on the plate.
But I mean, but there's a simple way of countering that argument, isn't there? Which is just compare the
original.
Yeah, compare the copy with the original or make multiple copies. Do they all have the same things on them or not?
And she actually did something like that. That's why those points, although they are the biggest that people usually throw around, they probably forget to read the fact that she, by herself, checked, I don't know, 20,000, 12,000, whatever number was the original number of those plagues one by one.
And they actually started out with a very high number of potential transient events, but they actually boiled it right down by eliminating and being rigorous.
Exactly.
They actually got it right down to quite a small number of kind of solid observations, for want of a better word. I mean, what do you? I mean, obviously, I think I don't know what are we meant to take away from the work is that. But you can tell me what you think in a minute. But
Well,
what I'm getting is that there appear to be these trackable transient events that appear to be some kind of object that is following a linear track.
mhm,
Um, and I think she says that they're almost certainly in an orbit,
yeah,
and obviously it is prior to us having any orbital satellites. So if they're not man-made, what are they?
yeah. I think that my point of view, my personal point of view, is that, for example, one of the big things in favor of all these
Hmm.
is, you know, the the fact that this repeats across many plates. It's not just a single thing,
Yeah.
and exactly because of this, I think you can easily remove also the part of it's only dust or it's only thing,
Yeah.
because
That's
it
easy
actually
to.
is repeating not only on one plate that is being checked. It's a lot of them,
Yeah.
and it repeats over. So
Hmm.
it's not something that is just by accident happening or by some kind of mistake,
Reproduction
reproduction
error.
mistake, right?
Yeah.
And the fact that also that she has a really rigorous methodological way to approach this, it's what has made her study even to be more
It's compelling, right? It's
compelling.
compelling. Yeah.
Exactly.
And I think again in the paper, in the conclusions, she talks about potentially either redoing it or doing it further, but training
AI.
an AI model to actually, rigorously apply an analysis,
Yeah.
and who knows what it can come up with. I think what we're left with in a way is that obviously you can't draw any firm conclusions because the data is 75 years old and all we've got is the plates, right?
Yeah.
We've got the plates and we've got some, shall we say, terrestrial events that maybe you could make some linkage with, but you can't prove that link, right?
Yeah.
And obviously you can't prove at all what these objects are. Um, but I think when we discussed doing this program last week, between us having a chat and then having another chat before we did this recording, I mentioned to you that I did some digging about using Copilot, and I asked some questions about what objects are currently orbiting the Earth and how many are in low Earth orbit, how many in high geostationary orbit.
Mm-hmm.
And I mean, the numbers are high, obviously, now. But I then asked questions about how many objects are, of the objects that we're counting that are of significant size, how many of them are not identified. I don't want to say unidentified. That has connotations. So how many can we not assign an identity to? That is this, or it's a rocket, or a spent stage, or a dead
Yeah.
satellite. And for low Earth orbit, I think it was something like 700 objects of significant size. And for GEO, the geostationary, which is like 24,000 miles out or more, it was much lower. I think it was under 100, I think. And the explanation that was offered as to what they are because they're being tracked, is they're either, although we don't know, they're either spent rocket stages or military satellites that they don't reveal what they are, stuff like that. And I also asked the question of how do we actually track objects in orbit, and it was quite interesting in that we used three methods. Is that right? What kind of? For low Earth orbit, we use optical and radar based tracking, and then for geostationary orbits, 24,000 plus miles, generally optical is not so good. We use more radar, but for anything that is at all active, there is a third layer of data, which is the data either provided by the satellite itself or by the company that launched it or who operates it. So the satellites themselves actually transmit. And I was actually reading about a satellite that's breaking the rules at the moment. Apparently, it's thought to be a military satellite, but apparently satellites have a particular band that they kind of transmit kind of I'm here data.
Yeah, like a transponder, like you have in planes or in
like a
even in
transponder.
drones nowadays. You have
Yeah,
to have
exactly. So there are tens of thousands of objects in Earth's orbit. Right? In fact, I think it's a big number. Right? It's a significant number, and there are unknown objects, unidentified objects. But as we were saying earlier, as you were saying earlier, because the sky is now so cluttered, it would be almost impossible to repeat what she has done.
Yeah, that's why she had to choose
Old plates.
old plates to do this. Nowadays, the only thing they have done during the study was also to compare with new star maps, let's say, of the sky,
Yeah.
just to compare and rule out also possible stars, for example.
Yeah.
So it is still unknown what those things are. It's just some
From
kind
the
of
plates,
weird astrophysical transients or something like that.
Well, it's either a natural phenomena or it's not.
Or it's not.
it's one or the other. Right? Yeah, I mean, it is. I don't know what. I mean, we've discussed this before. We both want to believe what it is, but you can't, can you? We just
Yeah, true.
and it's very frustrating that it's almost like this research it's like a scientific tease, isn't it? You know what I mean? It's like a almost significant, and it's tantalizing, but it's not definitive.
Yeah, I mean, even she mentions many times that there's still a lot of more work to be done.
Yeah.
And to go around certain things. Now, even if, well, now, I mean, it's hard to say what are those transients nowadays, but I guess that the main or the important part would be if this somehow could be reproduced, most likely you would need to have a special telescope or something outside orbit without, all the clutter.
On the moon.
Something like that, to be able to actually reproduce this kind of experiment and test.
I mean, I did think maybe you could do it, for example, with, say, ground-based optical telescope that could also do maybe infrared, and a bit like those other ground but using bigger technology, shall we say.
Yeah.
And I would imagine, you can get that app for a pad where you can just load the star chart and just point it up at the sky and it tells you
Yeah.
what the stars are.
Sky view is one
Sky
that,
view
yeah.
kind of thing, right? You would have thought that obviously we track all these objects that are in orbit, the ones that are identified and the
Yeah,
ones that are not. So I imagine a sky view that had all that data on
they
it.
do.
Right. I think I have read about something.
Well, I paid for the app, the subscription, or well, not subscription. Actually, I paid for the app. I think it doesn't have subscription,
Right.
and you can monitor there actually also
Satellites.
all the debris actually
Right.
of rockets, and they tell you from which year they are and so on. So you can actually track that thing.
So, but does it work like the sky view where you're pointed at the sky?
Yes,
and
it's
and
exactly
tells
in
you
Skyview. There's
It's-
no
oh, right,
change on that. It's the app. You open it, and you point your camera up to the sky, and you can
Right.
find objects and satellites
and it labels it.
and garbage from rocket stage burned, and then you can find, of course, the stars informations and
So you would have thought then that you could have a ground-based optical telescope with an infrared telescope pointing at the sky and referencing all that data. And if you were able to observe some kind of object and it wasn't in the sky survey, the Skyview data, then what is that object, right?
yeah. Although, like you said, you just have to account also for unknown objects that are
Known-
not cataloged.
Known unknowns, right?
Yeah. But again, one thing that I was still thinking about, I mean, you're pointing your telescope at a longer range, right?
Mm.
So I was wondering if those objects would not really appear into the.
Well, yeah, but I know that you can use a ground-based optical telescope to observe low Earth orbit stuff because people take pictures of the International Space Station
Yeah, of course.
using a ground-based telescope. That's at 250 miles, right? So my point is that the survey data of what is in orbit does include what is thought to be military stuff. They
Mhm.
just can't put an identifier on it. They know the object's there. So
Yeah.
I suppose what I'm getting at is if you were pointing, looking at an orbital plane, shall we say, and you saw an object in infrared and visible light, shall we say, or maybe just infrared, whatever, but it was not noted at all in the orbital data that we've got, which includes unnamed military objects. So we know the object is there and we can track it. We
Yeah.
just don't know what it's for, right? So if you found an object that wasn't in that database, what might that tell?
Yeah. You know what? Another interesting point that I remember just now of the study that she had to deal with is that the depth or the no, how do you call it, uh, the size or I forgot now the word, just went out of my mind. Uh, the scale of the plate varies sometimes. So to be able to match, sometimes you have to work very well into matching the same portion of the sky to the other plate that is in another scale.
Right.
And that could actually also create an issue with identifying that. And that's why also they wanted to include into an AI to automate this process,
Yeah.
try to make everything the same scale
Yeah.
so that the matches are done easier without affecting
Like the observation, is
the
it?
observation and adding extra artifacts into it.
Yeah. Yeah, you can imagine how obviously you could overlay them and then stretch them to match up reference stars, But of course, maybe by stretching it, you
added
make
something.
defects emerge that you wouldn't have seen at its original scale.
Yeah, exactly.
So I just kind of think fascinating stuff. I just don't know what conclusions you can
Well,
draw. That's the
I think the conclusion for me is that we need more studies nowadays to be taken this serious, or this with a very scientific procedure followed,
proper rigor, right?
proper. Yes, because nowadays, I don't know. I think there's a lot of people that claim to be scientists and they don't really do the real job. They just do claims
bullshit, right?
without getting the hands dirty, basically.
Exactly.
So not that I'm a scientist, but
Yeah.
I think it's obvious, or in the past used to be like that. You don't agree with something, then prove it by doing the work.
Yeah. Whereas of course what we see a lot now is just talking heads,
Exactly.
and they just, they may sound convincing,
Mm-hmm.
but a bit of digging or a lot of digging reveals, shall we say, well, a lack of rigor, right?
And I believe that if more scientists would take this approach of, okay, I don't agree with your project, with your study, I will prove
and
it
this
wrong,
is why, right?
and this is why.
Yeah.
We would be advancing even faster, probably, in discoveries and understanding of things like this one, transits appearing and disappearing, object.
But again, I think unfortunately, and we've had this conversation before, we live in an age of confusion, don't we? And that in an age of confusion, you can sell anything. And unfortunately, the internet / social media is just a totally confusing landscape in terms of you can literally say whatever you want. You don't have to be able to prove it. And because the reach is so great, you'll always find some bozos will fully and 100% believe you.
True. Yeah.
And it's that you're up against. It's all this like noise, isn't it?
Mm-hmm.
And the work she did with these plates was like a little beacon of clarity in all this noise.
Mm-hmm.
Quite refreshing.
Yeah.
Because obviously the subject she's approaching is quite, well, the kind of, not that long ago, these were career-killing studies, right?
Yeah.
Right? You just wouldn't say anything because you need to eat. Right?
That's true.
And then, of course, we get the age that we're in where in order to eat, you can just claim anything you want.
Mm-hmm.
And bit of flim-flam and a bit of marketing, and away you go. There will always be people who will believe you and buy your snake oil, right?
Yeah. Well, interesting topic.
Yeah.
And if you have any other opinions about it, please let us know in the comments. Thank you, Carl.
Yeah. Thanks, Rafa. That was. Yeah, we need to dig out more of this kind of stuff where we come to absolutely no conclusions at all.
All right. See you in the next episode.
Yeah. Bye.